Hey everybody, welcome back to Young Engineers of Today. You all had a good weekend. How was it? I forgot to grab some water before the class. I'm guessing everybody probably had a pretty slow weekend then. Well, that's good too. It's always nice. Well, we are going to continue with Godot. Again, not really all that surprising, but that's what we're going to do today. We'll get a little bit further into it. We'll get more into the scripting side. We'll get ourselves more sort of familiar with what's going on. And hopefully we can lay some of the foundation for getting this to up and running, getting this up and running. We'll give it a second. Wait for my computer to catch up. But yeah, why doesn't everybody go ahead and get Godot opened up? And here we are at the project view again. I'm assuming at this point you guys probably know what to do here. So we'll just go ahead and open up Godot Pong. And mine didn't save from last time. All right. No, wait. It had to have. There we go. Pong.scene. Yeah, in case it pops up with an empty scene, you can always, if you know you saved it last time around, you can go to Open Scene, and your saved scene should be there for you to open and take a look at. So thank goodness mine is still okay, all ready to go. I've got my two paddles, I've got the center line, I've got the ball. It was just a matter of making sure that had opened up. So let's see here. Did we have any? No, we didn't. We didn't actually get started on any scripting. But that's fine. That is actually ideal. So as a quick review, we've got our node 2D, which is sort of like the underlying, I guess, simulator that's going to run everything for us, which is why, it's empty and invisible. It just has all of our elements as children of it. So we've got Sprite, Sprite 2, Sprite 3, and Sprite 4, who are all children of Node 2D. And in fact, for our first thing, let's go ahead and name these something more helpful. So Sprite is going to become ball. For me, at least. See, when I click on it, I see that the ball becomes highlighted, so I know that Sprite is actually supposed to be the ball. If yours is something else, then we're going to name it whatever. For Sprite 2, since it is the center line here, I'm going to rename it center line, all one word. And the reason why I'm using lowercase and either one word or underscores is because we're going to be referring to these by name in our script. So I'm lazy. I like to have something that's a little bit easier to type. It's not exactly good programming practice to mix capitalization conventions like this, like Node 2D, the N is capitalized. Generally, classes and things like that will have a capital first letter. I'm not going to do that though, just because it'll make my life easier to type. So we're going to call this right paddle because it's the one on the right, and left paddle, because it's the one on the left. And looking at it, right paddle is actually just a teensy bit thicker than left paddle. Excuse me. Had a pretty impressive sneeze there. I managed to mute the microphone in time though. Anyway, so now we've got Node 2D, which has still just got the basic name that it comes with, but all of our sprites are now named helpful things because when you start having a lot of sprites, very necessary. It's not just good programming practice, but it's actually a necessary thing so you can ensure that you're keeping track of everything. So it's best to start that habit now. Your Pong game didn't save. If you try and go to File, Open Scene, do you have a .scn file anywhere? Like maybe called Pong or anything like that? Oh, sorry. Yeah, it's not file, it's scene. My apologies. That was the wrong thing. So scene and then open scene. And see if you've got anything there. Like, see, I've got this pong.scn right here, which was the scene that we made last Wednesday. It won't open the file. That's interesting. Does it give you like an error message when you try and... It just doesn't do anything? Uh, Okay, so I've got this area up here. You see how I've got like a tab that says pong.scn? You might just have the one tab. You might have multiple tabs. If you have multiple tabs, one of those might be the one that you just like opened. And it could be your saved scene. That's no good. It's definitely very strange that you have a saved scene there, but then it won't open either. That's a little concerning. don't know then. Oh, it's just you go to scene and then save scene. And that's all you should have to do. Oh, really? What happened? Oh, gotcha. This one over here. Yeah, that saves the resources. Okay, I get you. Oh, I'm sorry. That's no fun. Um, I guess so, yeah. All right. I apologize for that. I thought I'd covered saving in the last lesson, but I may not have. It may have been the one before that. So as it goes, it still has a bit of an unforgiving kind of saving system since it doesn't actually ask you if you want to save it before you quit. It just asks you if you want to quit. And if you hit quit, it won't save anything. It'll just discard all of your changes and close it down happily. Kind of like Blender or something like that. Blender does the same thing, and Blender actually used to be worse because if you accidentally clicked the X, it wouldn't actually ask you whether or not you wanted to quit. It would just quit. And if you hadn't saved in a while, it would just delete all the save, or it would just delete the progress you'd made since the save, including if you never saved it and you just started over, like you'd started from scratch. So yeah. Anyway, as a general life lesson for everybody, uh, save early, save often. Um, that's something that I still have trouble following, but yeah, it'll make your life a lot easier too, just in general. Okay, so as a little bit of review here, why do we have these sprites as the children of Node 2D? Because you can only have one parent. That's actually, yeah, that's one of the reasons. You can only have one parent. That's true. You cannot have a node in Godot have multiple parents. So that's definitely one of the reasons. However, you can actually go up the line too. So you can have a parent node which has a parent node which has a parent node. Children can have their own children. Okay, I like where you're going with this. It actually you can have children have their own children. You can think of it like a tree almost. A lot of times, um, you either have like parent-child nodes or trees, depending on oops, depending on whoever's explaining it, their preferred sort of visual aid. But yeah, exactly, Aiden. It makes it a lot easier, at least in this case, for Node 2D to communicate with them. But as you can see, this is why some people can think of it like a a tree, because you have, maybe you have a master parent in this case, Node 2D, that has one child node, but then they can have two children, and then that child can have three children, and one of them can have two, and one of them can have two, and so it kind of starts to branch out like a tree. But you can in fact, you can have sort of multiple layers of it. But yes, as you get further down, it's going to be like, say you wanted to have this one right here. That's going to be a 1, not just a random another arrow, although I do like my arrows. You wanted to have it affect this one. That's going to be kind of a pain because you have to travel all the way down this chain of command in order to get there. Likewise, if we wanted to look at the node structure for our own program, we could have structured it like so, with all of our sprites being children of the previous sprite. But that meant, like, let's say this is left paddle. When we wanted node 2D to talk to left paddle, it would have to travel all the way down this hierarchy in order to communicate with it. Which, it's not like a huge deal, it's doable, but it sort of increases the amount of work on our end. So by equalizing it so that all of them are children of node 2D, we only ever have to travel down the hierarchy one level, no matter what we want to access. And that makes our lives a lot easier. But you actually had a very good point there, Micaiah. You can only have one parent. It's not possible to have like multiple different parents, just because then it introduces weird dependency issues and things like that, and it's a mess. It's a mess. Now you can inherit from multiple different places. You can inherit from multiple different, like when we were talking about object-oriented programming last time around. You remember our example with person and student and employee? Well, what if we wanted, I don't know, grad student? Now, graduate students at a university, during their schooling, as they're getting their master's degree and whatever, they can opt to teach at that university as well. Basically, they can be like a teacher's assistant and, maybe take over a couple of the classes, help out with the homework and stuff like that. But depending on the professor, sometimes that means that they're going to be teaching undergrad students. Generally, it's like the introductory stuff, like, Econ 101 or whatever. But it's a possibility. So in that sense, they're both a student and an employee. It's not a perfect analogy, but it's close enough. So then we can have a class, a grad student class, that would inherit from both student and employee and have both of those things. That's totally doable. However, with the way that Godot is set up, we can really only have one parent node. Now, why was I so excited about object-oriented programming, other than the fact that you could inherit stuff like that? What's a major advantage of it over just like what I call it procedural programming, or procedure-based programming. Let's see here. What if I wanted to create a game that had monsters in it? How would object-oriented programming be better suited for that? All right, how about this? What if I wanted to add monsters on the fly? Object-oriented programming allows us to create copies of a template, right? Like classes, we can create instances of a class, so we can create a copy of that monster template and then basically include it into the game. Whereas with like a procedure-based programming style, we would have to hard code the different variables for all of the different monsters in the code. We wouldn't be able to have, like, the ability to just summon like a bunch. Like, how Pac-Man, there's very clearly 4 ghosts, and then there's Pac-Man. That's something that can be achieved with procedure-based programming, because it's not like, your score gets high enough and another ghost starts appearing and another ghost starts to appear and another ghost appears and another ghost appears and things like that. It's not like more ghosts get added to the game in order to make your life harder. Really, everything gets faster. But you keep the same 4 ghosts. So you can, if you wanted to, you could have... Oops. You could have code be like, Blinky, Speed, and Inky, Speed, and I forget the other 2 names of the ghosts, because they all have names. But regardless, you could have individual variables in there for each ghost, and that's okay. But if you wanted to do a game where, say Pac-Man, every time Pac-Man got another 1,000 points, another ghost would appear. You wouldn't be able to do this unless you wanted to hand code in like 100 more stats for ghosts. With object-oriented programming, you would be able to, because you could have a template for the ghost, and you could just create a new instance of that template, so a new ghost, with its own values, and boom, just like that, new ghost in the game. But anyway, that's the reason why I talk about that, is it's kind of a similar structure to the node structure of Godot. But you guys weren't here to hear me ramble about object-oriented programming again. You wanted to get started on some scripting. So I've got Node 2D selected, right? I clicked on the little scroll up here in the upper right-hand corner of Scene with Node 2D selected, and I got this Create Script for Node window, just like the Hello World. Now, just like the Hello World, we're going to keep class name empty. Inherits should automatically be filled by default with Node 2D. Language should automatically be GD script. Path, for you guys, is probably going to be empty. It might not be. If it's not, and it says path is valid, well, your life is easier. But for the bulk of you, path is empty is probably going to be what's listed here, and then the path field is actually going to be empty. So what I'm going to do is I'm going to click these little two dots, the two-dot button next to it. And here we go in the Save a File dialog box. I'm going to call it Pong because I'm good at names and I am very creative. But also it would be it's kind of helpful. It's going to be of type GD, which stands for, Godot script. Or Godot document, maybe. And then of course, we're going to be in our resource folder. So once that's done, I'm going to click Save. And here we are, res://pong.gd. Down here, it should say path is valid. If that's all happened, if you've done all that, fantastic. Go ahead and click Create. Bam. Extends Node 2D and function ready. This should look pretty familiar. So we've got the Node 2D, the extending, so it inherits from Node 2D. We've got some comments here. That's what those pound signs mean, or hashtags, or whatever you want to call them. The orange text, the orange-brown text, those are comments. Those are invisible to the computer, but not to us. So our lives become a lot easier because we can write notes to ourselves in the code. We can say like, oh, I put pass here because I don't actually have any information to put into ready. So, if I come back 6 months later, I can look at this and go, oh, okay, that's why pass is here. Or if somebody else is reading my code, they can go, oh, that's why pass is here. That kind of a thing. And in fact, that's what they've done for us. They actually have some pretty helpful comments here called every time the node is added to the scene and initialization here. Or member variables here, example, blah, blah, blah. They give us some hints as far as how to get started with the coding and where to put our stuff. Now, yes, hello, cat. The ready function. Who can explain it? Yes. Who can explain to me what that's all about? What does the ready function do? Does anybody remember? Well, okay, so Node 2D, or sorry, excuse me, ready runs almost every cycle. Certainly every time that the scene refreshes and all the things are re-added to the scene. which is something that happens periodically. But what we're going to do is we're going to set up a couple of variables, and we're going to put some stuff into ready, and then there's probably going to be a little bit more of me blathering on, and then we're going to continue with programming this. So the first thing I want you guys to put in is up here. You see how I've got a couple of lines here that I'm placing between these comments and the ready function. First one is going to be screen size, and the second one is going to be, I believe it's paddle size. Let me just double check that. Yeah, paddle size is fine. Now, from a JavaScript point of view, VAR is short for variable. Basically, what this is saying is reserve a spot in memory to hold some information. That's what variables are. And you're probably very familiar with variables if you've ever messed around with programming at all. But if not, you can think of a variable like a box to hold stuff in. And that box is like the stuff is generally information. So to reiterate upon the examples I've used before, monster health would be a variable. There would be a spot in memory reserved for keeping track of how many hit points a monster might have left, so that we can tell whether or not the monster is supposed to keel over from being whacked by a stick or whatever. So with these two variables, we're holding, as one might imagine, the size of the screen and the size of a given paddle. Now, why would we want to do this? Well, we'll get to that in a moment. But we'll add some more code inside of our ready function now. So first things first, we're going to initialize our screen size. So screen size, good lord, screen size equals viewport dot get rectangle size, I believe. No, that's not at all correct. Why is that popping up? I don't want to create a new resource. Please stop. It's get viewport rectangle dot size. So get viewport rectangle. What do you guys think that is? What do you guys think that means? Well, let's look back at our canvas. Check out that multicolored rectangle right there. Remember what I said that was? That rectangle is what the window size is, right? So if we were to, set this up so it would be running, when we were to look at the actual game screen, this would be the borders of it. Now, this area that we can view stuff through, it's also known as the viewport. So when we say get viewport rectangle, what we're asking for is the area that this rectangle represents. So get viewport rectangle, and then the period is an access modifier, which I'll explain in a moment, and then size obviously is the size of the viewport rectangle. So the access modifier is just is basically, it means, like, we want to go inside of this object and access something inside of it. So let's say we had our person class, and in our person class we had an age and a name. Just a very, very simple class. And let's say we created an instance of a person and we called them person1, and we said that person 1's age was 30 and their name was Bob. Good old 30-year-old Bob. Now let's say we're messing around with the code later on and we need to access Bob's age for something. So we can say person1 dot, there's a dot there, age. This right here, what we're saying is, hey, that object person1 that we have, go into it and give me their age. So we're basically saying, go inside of this and give me this value. It's just a direct access. So that's what the dot means. And the reason why they call it an access modifier is because we would be accessing information inside of that object. That's simply all that means. So in that sense, you might, be able to come to the conclusion that the viewport rectangle is also an object. It's an instance of a class. And you wouldn't necessarily be wrong. So the viewport rectangle has a bunch of information in it, including size. And we're taking the value of size and placing it into a screen size variable that we have here, just so that we can use that later. Yes, hello, cat. Now, I know it's slow going. I just want to make sure that we're all on the same page here, and that you guys know exactly why we're doing this stuff. The next thing we're going to do is we're going to get the paddle size. So paddle size equals get node. We're going to get the left paddle dot oh, good Lord. Get texture dot size. So we're doing the same thing here. We want to get the paddle size. So what we're asking is for one of these nodes, in this case the left paddle, and then we're asking for the texture, which is just a fancy word for the sprite that we used, and then we're getting the size. But notice how there are two access modifiers, so you can have a couple layers deep in classes and things like that. So for paddle size, we're getting the node, then we're getting the texture of the sprite on that node, and then we're getting the size from the texture of the sprite on that node. Kind of like Russian nesting dolls. There can be multiple layers to it. Finally, going to put in this weird thing, set process true. Now, what does that mean? Well, it has to do with this function that I'm about to create here. Function process, and then in parentheses, delta. This uses a variation of something called Node.js. Now, Node.js is a library. What's a library, you might be asking? Well, code is very, very simple, very explicit, and very literal. You have to break things up into very small steps in order to do more complex things. Even stuff like just printing something to the screen, taking input from a user, whatever the case may be. A computer, really the only thing a computer can do naturally is math. And then math on that math. Math on that math on that math. But with some clever applications of math, we can make computers do more stuff, like print things out to a screen, or send information to a printer, or track the weather, or whatever, talk to other computers. The problem is, since none of this is built into the code, basically every program that you wanted to do that kind of thing with, like let's say every program that you wanted to write something to the screen even, you would have to reinvent the wheel. You would have to go through and you would have to put in all of the code that tells the computer how to write things to the screen every single time, always and forever. Just be like, hey, yeah, okay, so a 3 means the color white, and a 4 means the color red, and a 5 means the color orange. And then, okay, so when I say 3 numbers here, the first number is going to be the X position, and the second number is going to be the Y position, and the third number is going to be the color. Okay, go. All right, now I can actually build the program I wanted to make. Every time, that would get exhausting. So, there have, throughout history, been some very, very kind people who do all of that work for us. And what they do is they package all of that code up and make it so it's possible for us to basically attach that code to ours. And there are built-in functions in a lot of languages that allow us to sort of import that information and allow us to reference it. Now these basically tomes of information and instructions, well, they're known as libraries. So rather than having to, again, reinvent the wheel every time we wanted to write a new program, say, you know, how to write something to the screen, we can import a library that does that for us. There's a standard I/O library in C. It allows you to write to the screen, even like terminal style. Allows you to just place words onto a screen like you would if you were using like DOSBox or something like that. White words on a black background. But there is a library to do that because in C they don't make the assumption that you always want to print something to the monitor. Sometimes you want to write a program that goes into an airplane black box or into a car engine, so it regulates, you know, fuel flow and keeps track of the status of the engine. There's no monitor on the car engine, so, you know, because people don't need a monitor in their car engine, so there's no reason for them to have that information to talk about, like to tell the program how to write to the monitor. So that's why something like that might not exist. Anyway, I'm getting sidetracked. Node.js is a library. what Node.js does is it allows JavaScript to call computations every computer cycle. Every time they pull the program for new things to run, JavaScript will send it a list of stuff that needs to be run at the same time. Now, human brains operate a lot like single-core computers, from what I understand. And that is to say, as much as we'd like to think we're good at multitasking, our brain never actually does two things at once. What it does is it splits its attention up. So let's say, you're trying to put on your shoes and having a conversation with somebody, or you're trying to write a paper and juggle some chainsaws. Don't do that. Just an example. What your brain is actually doing is it's actually engaging one part, like the part that juggles chainsaws, and then it's engaging the part that writes papers, but never at the same time. It'll flip back and forth between them super duper fast, like just a jillion times a second, so that it gives off the impression that we're doing two things at once, when in reality we are splitting our attention for microseconds at a time between two different tasks. And we are just swapping tracks, which is why they say, a lot of times that people aren't really good at multitasking, because your brain basically has to go okay, so what were we doing over here? Re-engage all of that stuff, pull that stuff out of memory, work with it, and then put it back in and move over to the other thing. Which is why sometimes you can have a really hard time holding a conversation with somebody while you're tying your shoes. Even you're really your shoes just aren't cooperating, and you're trying to tie them. And you're trying to tell somebody about your day, and sometimes you go because you're not tying your shoe very well, and you get lost in conversation. You forget what you were going to say next. That's a lot of times because your brain's just sort of swapping between two different things. It happens more often when you're tired, but it's still a possibility. Now, Node works a lot like that too. It's not actually going to be Node.js, I should say. It's not actually going to be running everything all at once. What it does is it gives the blocks of program to the computer, and then the computer lines them all up and then does each one in order, and then swaps between them, thousands, millions of times a second. It happens fast enough that it looks like there are multiple things going on the screen at the same time. That's how you can get, physics engines shooting off a bunch of, cannonballs into the air all at the same time, and they all fly off in their own directions and, impact with the ground and create craters and things like that. It's only been recently, with the advent of the multi-core computers, that that's something that actually does multiple calculations at the same time. Before, with a lot of single-core computers, with all single-core computers, something like that would be done exactly like this, where you would receive all of the information, the physics of each individual ball, and then the computer would crunch the numbers for just a fraction of a second and then go on to the next one, and it would do them all incrementally and in order. But it happens so fast, we can't tell the difference. Now, delta in this basically just represents the amount of time since this particular function was last run in milliseconds. And that's something that's a requirement of the process function in Godot. And it should be said, anytime you want to use Node.js and on any of these nodes, it's really confusing how the library is called Node.js, and then the discrete things in Godot are called nodes. That gets really kind of confusing. But they're two separate things. So anytime Node.js is called for a node in Godot, that function is going to be called process, always, with the underscore in front. And it's always going to have delta inside the parentheses, because it needs to have the same name so that it knows to run it every cycle, And it needs to have that delta so that it knows how long it's been since the last time it was run. Both of those things are a necessity. Now, that being said, process is where the bulk of our programming, the bulk of our scripting is going to go into. So let me just take a look at the script real quick because I don't have it memorized. Okay, we can add a couple more things real quick. We're going to add some more variables, and then we're going to call it a night. These are pretty self-explanatory for the most part. Variable ball speed. I wonder what that could be. Yeah, you're probably right. It's that. And then the next one is a little bit more tricky. It's going to be variable direction equals vector2, -1, 0. Well, that's weird. I wonder what that could mean. We'll explain that next time around. And then finally, constant pad speed equals 150. So, constant here just means that we're creating a variable that can never be changed. The value in pad speed can never be changed while the program is running. The only time we can change it is when we stop everything. We stop running the program, we stop everything, and we go back into this script right here, and we manually change this number. But we can't go like, oh, pad speed equals pad speed +1. Like that's not kosher, because we cannot change it. See, look, can't assign to constant. Because this is a constant, we can't do math on it in the program that changes it. Now we can do math using it. We can say like, oh, pad power up is equal to, or let's say pad power up speed is equal to pad speed times 10. So, you know, now we've put in a pad power up that speeds up one of the paddles by 10 times. And we've used the pad speed constant in it. But keep in mind that pad speed has not actually been changed by doing this. All we've done is we've taken, the value in pad speed and used it in this equation, but we're not actually changing the value in pad speed with this equation. If we change this back to pad speed, not okay, because now we're changing the value of pad speed, and we can't change a constant. Anyway, I'm going to go ahead and call it a day here, just so that you guys can head out on time. I know I got a little rambly at points here. We'll be more on the ball on Wednesday for sure. So let me go ahead and get those poll questions out. Once those are done, though, you're more than welcome to head out or stay for question and answer time. Regardless of what you do, have a wonderful couple of days, and we will see you on Wednesday.